Welcome back. We're in part 5 of Analytical Geometry and we're looking at circles. So previously we looked at those that were centered at the origin. Now we're going to look at some that are not centered at the origin. So here's an example of one. Let's say that the center, and you can see up here, the circle that I'm going to draw is at 1, 2, so maybe somewhere over there. And there's another point on the circle that's at 4, 6. I'm going to do it, say over there. The radius of the circle is 5. So the center here I've put at 1, 2. And I've put a point on the circle at 4, 6. And now we can draw a circle that looks something like that. I thought maybe I'd try one of these circle things here. But I think, is there a way of doing... No, you said it would be nice if... There's no ways I'm going to get this... Oh, maybe like that. Okay, so there's our circle. That looks not too bad, not too bad. Okay, so let's go back to our dear old friend Pythagoras and draw a right angle triangle here. That's how we made sense of circles, and how we've made sense of so much in this section, to be honest. Now, this x distance here from 1 to 4 is 3. And this distance here is 4. So we're going to nice Pythagorean triple. 3 squared plus 4 squared gives us 5 squared. Okay, we saw that before. 3 squared plus 4 squared equals 5 squared. That's the radius squared. But now the 3 isn't just the x value. The 3 we got to by going, well, we took 4 and subtracted 1. Maybe we didn't think through that explicitly, but this distance 3 from 1 to 4 we could have worked out by going 4 minus 1. And this 4 over here, we could have said, well, this 4, this y height, is 6 minus 2. Okay, let's look at another point on a circle. I think there will be another point on the circle that is over here. I think, wait a second, what about 5? And I think 5 will be also on this circle here. Okay, let's remove this part here and say, okay, in this second point in the circle, I think that that's still going to work. Kind of the radius will still be 5. Let's draw a right angle triangle and see. There we go, right angles. This distance is 4, 5 minus 1. This height of the triangle, 5 minus 2 is 3. So in this case, we went 5 minus 1 squared. Just to check if kind of our Pythagoras still works in this right angle triangle. And 5 minus 2. So 5 minus 2. Because, in other words, 4 squared plus 3 squared still gives us 5 squared. 4 squared, 3 squared, 5 squared. So what we've done for each of these points, and we could do it with any other point on the circle, is that this one stayed the same. So what we always ended up doing was creating some sort of equation like this. Maybe just take a while to take this in just to see, does it seem to make sense that in each case we subtracted the center of the circle, right? We subtracted the 1, we subtracted the 2, and we took a point on the circle. So our equation for this circle is this lovely equation here. Any x point on the circle minus the center, x value, plus y minus the y value at the center square gives us r squared. So in general, for any circle, if we have a center that is at AB, then our general equation looks something like this. So that bit we've already seen with specific values, but if the center is at AB, so if the center has coordinates AB, there's our general formula for any circle, centered at the origin or not. So these are not centered at the origin. So there's just an idea, and as you do these, you'll get into them. Of course, this is the first time you're seeing them. So I'll see you in the next part where we'll have to start completing the square, and then in our final one, we'll complete the square and do a few more examples to get into our circles a bit more.